Hello, this is Group 25, and my name is Gavin Liu. Today, I and my partner will introduce the Jami's architectures and the enhancement they propose. Jami is a peer-to-peer communication soft phone. Users can make phone calls and transfer files through the application. I will first introduce the conceptual architecture of Jami. The first thing that we did when we endeavored to figure out conceptual architecture is to draw the use case diagram. The diagram contains the main functions and the extension functions, as you can see in the image on the right. Functional and non-functional requirements both play important roles in the Jami development. Jami is a unique communication platform with a lot of different features. The main significant characteristic is its peer-to-peer distributed system architecture. Communications between users do not have to depend on a third party to relay their messages through the central server. Instead, each device contributes part of the network in Jami by helping others establish a direct connection using OpenDHT. This architecture can better protect users' privacy and give them full control over the personal data. The major driving factors in architecture design of Jami is concurrency. Jami should be a social media that could have multiple chat boxes running stably and securely. Jami will use malicious routing to prevent the software from fully locking up if one of the chat boxes crashes. Meanwhile, the other chat box remain unaffected. It is not an easy thing to draw the conceptual architecture of the program. This is the graph that we made first. We draw it in a simple way and use it to give us a sense of basically how each components contact each other. Some problems also occur in this diagram. In fact, daemon does not directly interact with the user. An LLC should be placed in between them, and plugin is controlled by daemon instead of interacting with the client. We then propose the final version. Jami has several client user interfaces used for interacting directly with users in different platforms, including Android, Electron, Juno, iOS, macOS, etc. The LLC is an interface between daemon and clients. The core of Ring daemon is located in SRC of the Ring daemon. There are mainly 5 managers and 1 instance file API. Managers include Call Manager, Configuration Manager, Presence Manager, Video Manager, and Plugin Manager. OpenDHT is a distributed hash table implementation. It has several features like store arbitrary values, listen operation, using value ID to distinguish different values stored under the same key, add an optional public key cryptography layer on top of DHT, etc. Plugin can be seen as a false interacting component in Jami, which has been added in Jami from 2020 as a call and chat feature for users from different operating systems. There are many interactions within our conceptual architecture, and below represents the dependencies of our 5 main subsystems. The first one is client to LLC. Client relies on LLC to transfer the user's request or ask to the center of the daemon. Then LLC to daemon. LLC communicates different APIs in daemon to acquire the information for the actions the users want to get or achieve. And then it's the daemon to OpenDHT and OpenDHT to daemon. While OpenDHT can provide data for daemon to accomplish some activities, daemon also will request the information stored in the distributed network. For example, helping the user to connect another user. The last one is plugin to daemon. Plugins can help users to personalize their experience. And this is the sequence diagram of the conceptual architecture on how one user can transfer the file to another one, which will be expanded a lot in the concrete architecture.
After exploring the conceptual architecture, now we are going to derive our concrete architecture. To better come up with concrete architecture, we have to update our initial conceptual architecture to fit the functionalities and non-functionalities of Jami. From this diagram, we can see the 5 main subsystems are remain the same, but there are few revisions inside daemon. By applying understand, we grouped many classes and files into different subsystems, and finally we got this dependencies diagram. We can easily see that we have correctly deduced many dependencies in our conceptual architecture, but it is surprised that there is a double arrow dependency between daemon and client. By looking at the interaction files and classes between them, we know there are some clients, like macOS Universal Windows Platform, can directly connect to daemon. Now we are going to dive in one of the major subsystems, daemon, as we can see from the left diagram. It contains a manager which can handle and manage different actions done by users and transform them into the interface. Dbus manipulates the API as a plugin chat handler, keeping the cooperation and moderation of the whole system. What security can do is to check if the certificate is allowed, validated, and permitted for contact. Document, as its name, is a directory composed of all documentation files. Moreover, media acts like a renderer in the daemon subsystem that mainly contains audio and video. And the helper consists of many helper packages, and install is used for daemon setup. There are other unexpected dependencies within daemon are worth to explore. Manager and deep media depend on each other because when manager wants to handle an audio information, it may interact with audio input or audio-related methods, and so did video. To make the inter-process communication successfully, Dbus has to depend on manager to coordinate the process lifecycle. Furthermore, manager and security will interact too, since the safety of each process has to be ensured. The reason why Jami subsystem cooperate pretty effectively is its unique architectural style, as we mentioned. However, there are few cases that Jami rely on a server, which are push notifications, the OpenDHT proxy, Bootstrap, name server, and term. For instance, name server is Jami's optional registration system, and it uses a blockchain to store Jami's accounts. We may consider about why Jami chose peer-to-peer instead of client and server architectural style. It is because its increased privacy, light infrastructure, high scalability, no bandwidth restriction, no size limit for file transfers, and more. Due to these significant advantages, Jami takes the server as an optional part. After constructing the concrete architecture, we update our sequence diagram of file transfer. When data transfer facade accepts the request from the user, the send file method will be invoked, and it will try to connect to another device using request connection in DHT peer connector. And finally, the ICE transport will be initialized and the negotiation process will begin in TLS socket. If on-connection request reply method has been called successfully, the peer connection method can be triggered to support the transfer. As we know, Jami is a program with relatively profound functions, but there is no end in the improvements of the software. Multi-device chat history synchronization is an enhancement we would like to add to Jami. Nowadays, many users have multiple devices at the same time to fit the need in various circumstances, including desktop and laptop. The life will be much easier if users could see the chat history, view the file or pictures sent during the chat on all the devices they own. In order to realize this function, we decided to add a new server specifically for the update and synchronization of the chat history. The conceptual architecture would change a little bit as well. When the data transfer in daemon tries to send the information to another user, it should also make the connection with the storage server. The server is in charge of taking the input and synchronize it on all the user's devices. There will be a flow back and forth between the daemon and the storage server. Analyzing the conceptual and concrete architecture has brought us many insights of how the system works precisely. By applying understand tool, we observed the dependencies between different modules and got a more comprehensive understanding of the entire Jami system. Besides, we have learned how a new feature impacts on the whole system's behavior. And I believe this will be really helpful for our future development. Thank you.